Hello everyone. Today's lecture we are just going to talk about the concept of normalization, right? Why we need this normalization. With the help of couple of examples, we are just going to discuss normalization concepts step by step, right? So here we go. Before proceeding in this lecture, let's talk about what we are going to learn, right? So we will talk about redundancy. Why we talk about redundancy is why we need normalization. This is only because of this redundancy, right? So we'll talk about the concept of redundancy also. We will also talk about impact of redundancy. If our database is having redundancy, what are the impact of redundancy, right? Then we will talk about the normalization concept. Then we will talk about first normal form, then second normal form. So at the end of this lecture, you are able to learn how we normalize our database into first NF and second NF, and what are their advantages. So we will proceed in this lecture. So here we go again. So what is redundancy, right? Suppose we have a database of student table. Now from a student table we have three columns. The name of you can see the column name is first column name is student roll number. Second column name you can talk about student name. Then you can talk about department, right? So to understand the concept of redundancy, consider this example. Now we have chosen this student roll number is 11, 12, 13, 14. We don't bother about the roll numbers, right? We have got some random entries on this. And then we have a student name as a student 1, a student 2, a student 3, student 4, a student 5 and a student 6. That students that belongs to different departments, right? Corresponding to student name, we have just mentioned the name of their department, right? Suppose you say student 1 that belongs to computer science, right? Then you again check at this student 2 that belongs to electrical department, right? Again from the same student 3 that belongs to computer science department. In similar fashion, we have just made a table for student 4, student 5 and student 6, right? So here you can see, you can find from this, you can find from student roll number column, you will find 11 is different from 12, 12 is different from 13, 13 is different from 14, 14 is different from 15. So there's uniqueness in this table, right? So you will find that there is no repetition of record in this column, right? And again, if you check at the student name, you'll find student 1 is different from student 2 until their names are same. Now you can say unless their names are same, right? So if you check at this column department, you can find that computer science, electrical, again computer science, oh god, then again mechanical, then computer science, then computer science. From this you can see that computer science is repeatedly repeated. And if you check at this column, you will find that computer science is repeatedly repeated for the 4 times. And if the information is repeated again and again unnecessarily, you can say, so that you can say is called a redundancy in the database. And from this table you will find that this kind of redundancy has very low impact, right? Suppose we have a database containing tables that have more columns. Now consider the next slide. Look at this. Okay, that is actually a redundancy. So look at this. What is redundancy, right? Again, now what I've done is I have added one more column that is called D name, right? Here you can see that suppose Professor CSC, right? Professor CSC is Dean of Computer Science, and again you will find where there is a computer science department corresponding to computer science department, there is a dean name that is Professor CSC. And if department name is repeated for the 4 times, computer science is repeated for the 4 times, then you will find that the same name, that is dean name, is repeated for the 4 times. And here you can see the combination of repeated information. You will find, suppose you can see this is repeatedly repeated information. Now you can find the two records are that one belongs to department and D name. They are repeated for the 4 times. You can check from this where I have just highlighted this rows, right? From the, you can see orange boxes. You can see over here from the slides. So now the impact of redundancy has been increased. You can see that first time from the first previous slide you have find that the impact is only at the department. So you have got the redundancy but having very low impact. But if you add some more information or add some more columns and information is repeatedly repeated, so you can see that is going to impact more. If you can say, let's check it out, right? Again, suppose let's consider one more slide again. If you check at this, now look at this, right? What we have done, we have added again department assistant name. Here you can check this department assistant name. What you will find that what I have taken, actually I have assumed that assistant underscore computer science, right? Assistant underscore electrical. Here you can find that this information department assistant name, where is the computer science, you will find the computer science, you will find corresponding D name, that is same, that is Professor CS. And again, if assistant is one in that particular department, you will find the same assistant. So here you can see where you will find computer science department, the D name will be going to be same, and again the assistant name is going to be same. If we are assuming that there is only one D at a particular department and one assistant at a particular department. So for this way you can see the information is repeated unnecessarily. And now what is the impact of redundancy? If we understand that redundancy is what? Actually unnecessary repetition of information, that is called redundancy. And if information is going to repeat it in this way, this is only the 6 records you can find out from student 1 to student 6. And if you believe or you can understand, if there is 1,000 or 5,000 students or 5 lakh students, or suppose you can understand a global database of various Facebook or something else, right, where you can find several information is repeated again and again. So how you can minimize this kind of redundancy? So what actually redundancy impact? What are the disadvantages you can say the redundancy having in a database? So storing the same field values more than once is referred as data redundancy. This is definition of redundancy. Now let's talk about some disadvantages of redundancy. We will understand this disadvantage with the help of examples in the coming next slide as an anomaly. So the first disadvantage is storing values multiple times wastes space. The concept is very clear. If you are going to store the dean name, department name and department assistant name, as you've seen from the previous slide, you are storing the same information for student 1 also, for student 3 also, for student 5 and student 6. You are storing the same information again and again. So this is going to waste space. Second problem, when you talk about when a field value changes, multiple occurrences needs to be updated. Suppose, let's take an example. Now the head of the department has left the, or a dean of the department has left the college, right? And now the new dean has joined the college, and you can say the name of new dean is Professor CSE. Now you have to update in your database also. What you have done, the DBA or database administrator has changed the name from Professor CSE to Professor name for the student 1, for student 3, for student 5 and for student 6. So every time, let's try to understand this point. Every time when you want to change some field values, you have to change at every occurrences of that particular event, right? So if you are changing for student 1, similarly you have to change this field value for student 3, for student 5, and for student 6, right? Third problem occurs if you forgot to change the values in any of the records. Oh, this happens, right? Suppose you have changed the dean name for student 1, for student 3, for student 5, but unfortunately you forgot to change the dean name in student 6. Now let's what happened. If department head is unique, assume, right? For the student 1, student 3, student 5, the dean name is Professor New, right? But for the student 6 who belongs to same department and have the dean name different, and that is now Professor CAC. So Professor New is different from Professor CAC. It means there is inconsistency in data, right? The data does not agree with itself. So there is inconsistent data, right? So what is the solution, right? Solution is normalization. Solution is for what? Solution for redundancy is normalization. When we talk about normalization, normalization is a process of organizing the data in the database to avoid data redundancy. To be very clear, you cannot remove data redundancy, but you can minimize the data redundancy, right? So there are three types of anomalies we will talk about that will occur if the database is not normalized. Means database, if you are not using the concept of normalization, right, the three kind of redundancy or the three kind of anomalies you have to meet, that is insertion anomaly, update anomaly, and deletion anomaly. Let's try to understand this insertion anomaly with the help of an example. Right, first we will talk about update anomaly, right? Consider this table which contains the 5 fields as you are seeing: a student roll number, a student name, department, dean name, and department assistant name, right? Again, the field values are same: 11, 12, student 1 to student 6, and they have corresponding to student name, we have a department name, and department name to the dean name, and the dean name to the department assistant names. So this is a basically record, or you can say just a sample of a database, right? What happens now? Look at this. If you see from this, right, now you can say, yeah, just go previous. Professor CAC is currently the Professor CAC is the dean of computer science department, right? Now what happens, the Professor CAC, for some reason he left the college, right? And now the new dean has arrived and he joined this college. So the idea is you have to update in your database also. So you have to update this Professor CAC in your database, right? So you have updated Professor CAC to Professor New. Now we are assuming that the dean of new dean is Professor New. Okay. Now the new dean of computer science department is Professor New. Now in similar fashion, you have to update this Professor New to Professor CAC. So at every place where the Professor CAC name is mentioned, you have to update with the Professor New. So let's try to update this, right? So look at this, you have updated for student 1. Now for student 1 you have updated the dean name. For student 3 you have updated the dean name. For student 5 you have updated the dean name. Oh, but look at this, student 6. You have till now, or you unfortunately forgot to update this dean name, right? You, for student 6, the dean name is still Professor CAC. So this needs to be updated. Unfortunately, if you forgot to update this dean name, that this seems the data disagreed itself, right? How data disagree itself? If suppose the dean name is unique for a particular department, and for some query if you ask the dean name for a computer science department, it will give you the professor new or professor CHC. It will get confused, right? How for this student one, it belongs to computer science department and dean is professor new. For second student 3, the dean name is professor new, and for student 5, for student 6, this is professor new, but for student 6, the dean is different. So how is it possible the dean name is there are two deans for a same department if the dean is only a single person for a particular department? So this from this table you will reach to a conclusion that the department computer science are having two dean, that is Professor New and Professor CAC, which is according to the college policy or according to the university policy is not good if we are assuming that the department is having only one dean, right? So this type of anomaly we call update anomaly. Let's try to understand this next anomaly, that is insert anomaly, right? So consider again this table, right? Now consider in your mind that department field is not going to be null, right? Suppose if you want to insert this student 7 record, right? uh, and you are unaware about his or her department till now because student 7 is in waiting list of admissions, right? But it is not clear that student 7 in which department he is going to get admission, right? So if you want to insert this student 7 record in this table, and according to the database design, that department field is not going to null. So when you want to insert this record, you can insert this roll number, you can insert a student 7 name, but still if the department is not clear, you cannot insert into this student 7 record in this table, right? So this kind of anomaly we used to say is insert anomaly, right? Now let's try to understand the delete anomaly. Again consider the same table. We are considering the same table again and again so that it is very clear how the anomaly behaves, how if the anomaly exists if we are not going to normalize our database, right? So look into this. Now we have added one more column over here which is in the considered example, that is subject opted. These are the optional subjects. Let's assume to make you understand that these are the artificial intelligence, environment, operation research. These are the optional subjects running in the BTech final year, right? Now the condition for running elective, these are the open elective, these are not the compulsory subjects. So these are open for electives, right? So students can choose any one of these subjects, right? And according to the college policy, if a subjects is opted by more than 20 students, then only the subject is going to run in that particular college. Suppose let's say, to make it very clear, if artificial intelligence, if 20 or more than 20 students are going to opt for this artificial intelligence subjects, then this subjects is going to be run or taught in a these 20 students, right? So this subjects is going to run for a particular college as an open elective for the same all subjects. So consider this conditions, right? Now what happens, suppose 20 students opted artificial intelligence, right? And all these subjects, that is environment, operation research, industrial relation, entrepreneurship, and human computer interface, suppose all the conditions are satisfied this for artificial intelligence subjects, for environment, operation research, industrial relation, and entrepreneurship, it means these subjects are going to be run because all more than 20 students have given the choice for all these subjects. So these are the subjects that are going to be run for that particular college. But consider these subjects, that is human computer interface. The student only 5 to 6 students have given choice or shown interest to take human computer interface as a subject. Now let's say what happens according to the policy of the college or department, if a subject is opted by less than 20 students, that subjects have to be dropped out. Means that subject is not taught in a particular semester. So let's say now this. And in a database, when you have maintained the record that the student 1 is opted for artificial intelligence, student 2 is opted for environment, student 3 is opted for OR, student 4 for industrial relations, and student 5 for entrepreneurship, and student 6 for SCI. And now if this subject is not taught in this semester, it means that you have to delete from the subjects opted list, right? So you have cut in this results. So this entry is going to be deleted. But look into this, when you try to drop out or delete this entry from this particular column, this whole row is going to be deleted, right? It means when you try to drop out this particular subjects, that particular row is going to be deleted. So what is the consequences of deleting this subjects? This will delete the whole record of student 6, right? So this kind of anomaly we used to say is delete anomaly, right? When you deleted this particular subjects, the entries corresponding to this rows are going to be deleted. So such kind of anomaly we used to say delete anomaly, because this whole record of student 6 that belongs to this subjects opted is going to be deleted, right? So to overcome the three kinds of anomaly, right, we use the concept of normalization, right? What are the three kinds of anomalies we have? That is insert anomaly, delete anomaly, and update anomaly, right? So let's talk about there. There are first normal form, second normal form, third normal form. Then we'll talk about BCNF. Then we have fourth normal form, and fifth, and so on, right? So let's try to understand first what is actually the first normal form, right? A database is in first normal form if it satisfies the following conditions. What are the conditions? Contains only atomic values. Let's try to understand the concept of atomic values. The values which is not going to be further divided, right? If you do, you can divide your values further. That values you can say is not atomic, right? Means atomic values are those values which you cannot divide further, right? No two rows are identical. Means the two rows, all the entries in the rows must not be identical, right? All entries in the column must be of same kind. So let's try to understand these three conditions with the help of an example, right? Look at this. Now consider this employee table, right? Just if a question is asked from you that from seeing this table, can you say that this table is in first normal form? Look at this. This is Melvin, this is Edward, this is Alex. These are the employees' name, and corresponding to employees, their ages are given and their department are given, right? So can you say this table is in first normal form, right? Let's try to understand this. Let's try to satisfy all these three conditions one by one. Consider the third one. All entries in the column must be of same kind, right? You can see from this table, from this column itself, that this column contains only employee name, right? This column does not contain the age, means that is of same kind. If employee name is given for a particular column, this column is going to contain only employee name, not the age, not any mathematical number, right? And consider this, if the column contains only the age group, now this column is going to be contain only the numeric numbers, not the alphabet numbers, alphabet, characters. Similar for the departments, the department is not going to contain the name, right? These are going to contain only the department names. So this condition is going to be satisfied, that all columns must be of same kind. So the third condition is satisfied. We can say that this condition is satisfied. So till now we can say that this table is in first normal form. Now consider the second. No two rows are identical. Means suppose if you consider these three rows, right? This is Melvin, this is Edward. So employee name is different, right? So these two rows are different in some manner, right? So their employees name are different. So in spite of saving, if consider the Melvin and Edward is the same, but their names are different. So the two rows are going to be different, right? So all these three rows are different. So condition 2 is also satisfied. Now let's talk about condition 3. Contains only atomic values. And let's, if you remember that starting of this slides, I have talked about what are the atomic values. Atomic values are those which are not further divided, which cannot be further divided, right? So if you talk about Melvin, right? Melvin age is 32, and if you look at this department column, you can find he is working in two departments, that is marketing and sales. And Edward, this is 45, and he's working for the quality assurance department, and from the Alex is working for the human resource department, right? You just correct this spelling from HUMAN, human resource department, right? So if you can see from this, for the Melvin, he is working in two departments. Can you check that these values can be further divided, right? So this is not the atomic values, right? Because marketing and sales are the two different departments. So this cell contains the non-atomic values. To make it more clear, consider the second one. Edward is working for quality assurance department, right? And this is an atomic value because you cannot divide the quality assurance department, right? Similar, human resource department, this is a unique department. You cannot divide the department of human resource and quality assurance. But for the same thing, for the first row, you can find for Melvin, he's working for the two department, and these are the two different departments, and these sales values can be further divided into the marketing and sales. Or you can understand in this way also, Melvin is working for marketing department, Melvin is working for the sales department, right? So for this condition is not going to be satisfied. So we can see from this table, this is not in first normal form, because instead the two conditions are satisfied, but the third condition is not going to be satisfied, which is it contains atomic values. But unfortunately, if you can see from this table, this contains the non-atomic values, right? So how to make this table into first NF, you can divide the Melvin into atomic values, department atomic values. So look into this. Right. What I've done, I have divided Melvin age 32, that is working for the marketing department. We have just added one more row for Melvin by dividing that Melvin works for marketing department and Melvin works for sales department, and same for Edward, quality assurance, and Alex for human resources. Now again, can we say this table which we have constructed is in first NF? Yeah, of course, this is in first NF. Let's see or try to satisfy all these three conditions. Now, contains only atomic values. Try to fit the first condition, that Melvin 32 marketing. All these entries are unique and atomic, right? Because you cannot divide the name of Melvin into two parts. You cannot divide A's into two parts. You cannot divide the department into two parts. So these are the atomic values. Again for Melvin 32 and sales. Again you cannot divide these all entries of second row into some values. For the Edward and Alex, you cannot divide these values, right? So all the values that this table contains are atomic. So first condition is satisfied, right? Now let's talk about the second condition. No two rows are identical. that suppose look at this first row. Melvin, age 32, department marketing. Melvin, age 32, department sales. These two entries of first and second rows are same, but department is different. So you can see from this, no two rows are identical. So this row and this row, in spite of having the same employee name and same age, their department is different. So these rows are not identical, right? In the department aspects. So condition 2 is satisfied. All entries in the column must be of same kind. Again, if the name is, if a column contains the employee name, the name is there. If column contains the age is here. If column contains the department name is here. Department does not contain the employee name, and employee name does not contain the department name, right? And age contains the numeric values and same thing. So the all entries in the column must be of same kinds. Means if you are specifying some column for having some values, that values are going to be of same kind, right? So this is in first normal form. So for being for if you are going to normalize your database according to first normal form, you have to take care of all these three conditions, right? So this is in first normal form. So what is the advantage of first NF, right? So let's consider an example to understand this concept of first normalization form. Why we have normalized our database into first NF. To make you more clear, let's consider an example. Now consider this table. This is not normalized because this row contains the values which are in the nature of non-atomic, right? So now suppose consider any reasons. Now Melvin has left the sales department, right? And Melvin only works for marketing department. So company has to delete the Melvin record from the sales department, simultaneously keeping the Melvin record for the marketing department, right? So in this case, if the database or our table is not normalized, that in this case, this record or this row has to be deleted. And unfortunately, look into this, when you delete this record, this Melvin record is going to be deleted for the board department. You have to delete only for the sales department. But when you delete this record, this row, then the two rows simultaneously are going to be deleted. That Melvin that works for the marketing department and Melvin that works for the sales department is going to be deleted. Now there is no record of the Melvin, right? But what we need to keep the record of Melvin. He still works for the marketing department. So that is a big loss of information, we can say, if the data is not normalized. Now look into this. If the table is in first NF, right, it contains the atomic values. And now we can see that Melvin is not working for the sales department. Melvin works for the marketing department. So in this case, if table is normalized, then there is no problem, right? You can see we can delete the sales department and simultaneously the record of Melvin, who is working for the marketing department, is now safe, right? So this is the advantage of first NF. Actually, we call this as a delete anomaly. To overcome the delete anomaly, we generally use first NF, right? So this is an advantage. So before proceeding towards second NF, you must have a brief concepts about what is primary key, what is candidate key, what are prime and non-prime attributes, and what are the full functional dependency. I must suggest you, before proceeding for the second NF, you must read it out for these all these three terms. uh, I am just going to give an overview about primary key and candidate key, right? So look into this. Primary key is that key that uniquely identifies a record, right? For if you are considering for a particular student, then a student roll number, right, in a student table is going to be primary key, because a student roll number is going to be unique for each and every students, right? You cannot take a student father name because two students can have the same father name. In similar fashion, you can say you cannot take a student name as a primary key because the two students can have the same name. But on the other hand, if you take a student roll number as a primary key, then it means the two students may not have the same roll number, right? So roll number is going to be unique, right? So, and second property of primary key is that primary key is not going to be null. For each student you have to assign a roll number, right? This is going to be must, right? And candidate key, if I say in a short, that is collection of primary key, right? What are prime and non-prime attributes? Those attributes which belongs to candidate key is called a prime attribute, and those who does not belong to candidate key are called non-prime attribute. Suppose if we say that candidate key are roll number and registration number, right? For example, say what are the candidate keys? Let's try to understand this. Now say that a table contains a roll number and registration number of a student, and we have a choice. We can take roll number as a primary key or registration number as a primary key, because both are going to be unique for a particular student. So these both are the candidates of a primary key, right? They both stand equally for candidature of primary key, right? So what are the attributes? What are the prime attributes, right? So if you see that the different values of registration and different values of roll number is attributes, and roll number, suppose a student 1 having roll number 1, student 2 having roll number 2, so these are the prime attributes because these attributes belongs to a candidate key, right? Similar fashion, a student name, that is non-prime attribute because they are not the parts of the candidate key, right? So now let's talk about full functional dependency. Full functional dependency means, suppose for example say roll number derives the name, right? It is clear. When you have a roll number of a student, you can answer the name, right? You can give the name of that particular student, right? Suppose anyone is having the roll number, right? Is asking for the name. You can search it out in your database as a primary key, taking a roll number as a primary key, and corresponding to that primary key, you can find out his or her name, right? So name can be derived from the roll number, right? So this is name is fully functionally dependent on roll number, right? What is partial dependency? Let's try to understand this. Roll number comma gender derives name. In this dependency, you can see that name can be derived from the roll number. There is no need of gender, right? Gender can be only 3 genders: male, female, and trans, right? But if you can check out this we don't require for determining the name, right? We only require the roll number. If you know the roll number, you can get the name. You don't require this gender, right? So this kind of dependency is called partial dependency because name is going to be dependent on only on roll number. If you know the roll number, you will get the name. Name does not require gender. If you know the gender, you cannot get the name. So name is not going to be dependent on gender. So name is going to be dependent on partially on this roll number. This collection of keys is called candidate key, right? This is candidate key. So what is 2NF, right? Our relation is said to be in 2NF if is it in first NF. First you have to make your database in first NF, then you can proceed for the second NF, right? So for the second NF, the first condition is must that it should be in first NF, right? Or you can say in first normal form. As per the second normal form, there must not be any partial dependency of any column on primary key, right? It means there should not be any partial dependency, means there should be a fully functional dependency of any column on the primary key, right? It means that for a table that has a concatenated primary key, each column in the table that is not a part of primary key must depend upon the entire concatenated key for its existence. If it's not, then this is fails the second normal form. You cannot say that is not going to be second normal form. That statement seems to be bulky, right? This gives you some kind of trouble, right? So let's try to understand the second normal form in with the help of some suitable kind of examples. So what you have to keep in mind is that a relation should be in first NF. That first normal form should be there, and then this condition, prime and non-prime attribute. You must have to keep in mind that each there should not be any partial dependency. Means the non-prime attribute should be fully functional dependent on the candidate key, right? You must keep in mind. So if you are not going to keep in mind that, do not bother about this. Let's try to understand with the help of some kind of examples, right, in the forward lecture. So let's try to understand the concept of 2NF, right? Suppose schema is given. First, understand the term schema. Schema is nothing but a collection of column names of a given table. If you are talking about a schema, then for this table schema is student ID, student name, car ID, car name, car price. So its schema is given, right? You must keep in mind that a question is always contains the given schema, and they will also give you the functional dependencies, right? And then the question is asked that whether this schema or this relation is in 2NF or not, right? So let's try to understand this. This table is in first NF, right? So look at this. A student ID which is written in bold is primary key. Car ID is written in bold, it is also a primary key. So this both act as a candidate key, right? Now there is a student name, car name, and car price is given over there, and then there is some functional dependencies is also given, right? So whether to test this is uh, this is in second NF or not, let's test it one by one, right? So before we proceed in this example, let's recall the conditions. The For the second NF to be hold, the relation must hold the first NF condition first, and second, the relation every every non-prime attribute must or fully functional dependent on every candidate key. What is prime attribute? This is a prime key, or you can say this is a candidate key, right? These two are the candidate key. And look into this, if a student ID is a part of candidate key, so these are the prime attributes, right? And car ID is a part of primary attribute, so these are the car ID is candidate key, so these are the attribute, prime attribute, right? So look at this. Other than this student ID and card ID, which is a part of candidate key, rest are the non-prime attribute, because the student name is not a part of candidate key. Car name is also not a part of candidate key. Car price is also not a part of candidate key, right? So it is very clear which is prime attribute and non-prime attribute. These attributes are prime, car ID and student ID, and these attributes are non-prime, right? And some functional dependency is also given. The student name, car price, and a student ID derives a student name, car ID determines car name. So let's try to understand. According to the second condition, every non-prime attributes, in this case non-prime attributes are what? A student name, and car price, that should be fully functional dependent on each and every candidate key, right? So this student name must be dependent on both, right, for fully functional dependency condition to be hold. Now let's check it out one by one attribute, right? So if we look at student ID, right, so this is a prime attribute, so we should not be bothered about this. Let's talk about car ID. It is again a prime attribute, do not bother about this. Now let's talk about student name. According to the second condition, every non-prime attribute must be dependent on the every candidate key, right? So student name, just check it out. Is student name is fully functionally dependent on student ID or car ID? So check out. Here it is, you can see that there is partially dependency between student name. Student ID determines student name. It simple means that student name can be derived from student ID. There is no need of car ID, right? Or in simple word you can say, now look at this table, right, to make this point very clear. Functional dependency in real world, right? Suppose a student Melvin, right, purchase a car BMW in 45 lakhs, right? And Edward, or consider Alex purchased the same car in the 45 lakhs. You can see from the table that student name does not depend on car ID, right? How does, you can see that price depends on student name? To make this point very clear, if suppose Melvin purchased the car, he has to pay the same price, and if Alex purchased the car, he has to pay the same price. So price is not going to be dependent on the person who is purchasing it. It means the price is not going to be dependent on the student name, or you can say that student ID does not have anything to do with the car ID, right, in this case. So if a student ID derives a student name is can be derived directly from the student ID. There is no need of car ID, right? So there is a partial relationship. So we, and according to this relation also, it is given in question that a student ID is partially dependent on the student name. The student name is partially dependent on student ID. So it means there is a partial relationship, right? And a student name, this which is a non-prime attribute which depends on student ID only. It does not depend on car ID, right? So this is non-prime attribute, and according to the second condition, every non-prime attribute must have to be dependent on each and every candidate key. So student name depends on student ID, one candidate key, but student name does not depend on car ID, right? So this relation is not in second NF, right? So anyone can argument about why we need second NF, right? So suppose let's consider another example to understand what is the advantage of second NF. Now let's talk about, suppose car ID which is having 32 number is price has been updated. Now the car which is having car ID 32, now it becomes 50 lakhs rupees, right? For anyone who wants to purchase the car having car ID 32, he have to pay now 5 lakh more. It means he has to pay 50 lakh rupees, right? So if in case the price is updated, right, so you have to make update at many columns. This table contains only 4 columns, right? You can see from this contains only 4 columns. So where the car ID 32, price of car ID 32 has been updated to 50 lakh rupees. Now you have to change, you have to make change in this column also. You have to make change this column also. In several fashion, who purchased the BMW car, any number of person can purchase the BMW car. So at every place you have to update the new price, and that is going to be that can give birth to an update anomaly, right? So first NF can be used to minimize the impact of delete anomaly, and second NF can be used to minimize the impact of update anomaly, right? So this is the case. So in order to remove this kind of update anomaly, what we can use, we will try to normalize this table in second NF, right? So how we are just going to do that next, now see in the next slides, right? Now look at this table, right? Look at this table. This is not in second NF, but it is in first NF, right? To make this table in second NF, what we'll do is we will decompose this table into a smaller table so that the partial dependency can be converted into the fully functional dependency. So what we'll do is a student name is derived from student ID, or you can say that there is a partial dependency which is given in question also, that student ID determines student name. So you select these columns in which partial dependency is shown, right? So what we'll do is we have separated this column, a student ID and student name, right? So here you can find it out. Now the student name is fully dependent on candidate key for this table. For this table, the candidate key is student ID, or you can say for this primary key is also student ID. So student ID determines the student name, right? And student name is fully functionally dependent on student ID. Look at this. Second, again we have seen that the car ID has a partial dependency, or car ID determines the car name. Now again what we have done, so we have decomposed this table into in this fashion, right? So now we have car IDs and then car name corresponding to this. Now we will make a table in which we will put both the candidate key, the combination of both the candidate key. You must have to keep in mind, for every partial functional dependency you will make a column, you will make a table, smaller tables, right, to remove the partial dependency and to convert it into fully functional dependency, right? So now from these two tables you can see that these are the non-prime attributes, right? A student name is non-prime attribute. Now a student name, which is non-prime attribute, is fully functionally dependent on student ID. So this table is in second F. For this, car name and car price is fully functionally dependent on car ID, and for this reason these are the prime attributes. So again we do not have to bother about the student ID and car ID. Every time we must have to keep in mind that for the second normal form to be hold, every non-prime attribute must be dependent on, fully functional dependent on prime attributes, right? So this is an example. Hope it helps in making second NF more clear, right? So here we can look out for the advantages also. Suppose the car price has been updated now, right? So what it will do is, in this table you will update this price, BMW price, to 50 lakh rupees, and you will find that automatically if you update this in price, you will update this price to 50 lakh rupees, it will automatically reflected in your car ID. So no need to worry about we have to update it at several places. You have to update this price at only one place, right? Suppose you have updated for 50 lakh rupees, for this place only you have updated the price at this place, and automatically 11A, who purchased the car ID 32, right? 32 is connected with this and he has to pay 50 lakh rupees, right? You have made update only this place. Again look at this, 11D also purchased the car ID 32, means he have to pay again 45 lakh rupees. So for this and for this they have to pay 50 lakh rupees. Now for this time you should not have to make update here and here, not at the two places, but only single update is required. So this will reduce or minimize the impact of update anomaly, right? So this is the biggest advantage, you can say, of the second NF we have, right? So we are at the end of this lecture, right? So what we learn in this lecture is we try to understand the concept of redundancy. Then to overcome the redundancy, or to overcome the impact of redundancy, we have understood the concept of normalization, how we will do that, and how the normalization is going to help to overcome the different kind of anomalies we have. We have talked about the three kind of anomalies. Then we talk about first NF, right? In this we have talked about how we can make our database into first normal form, and then we are given some concepts of atomic values also. Then we talk about second NF. Second NF is little bit tricky, but I try to make you more clear with the help of example so that you can understand how the second normal form helps in a real world situations, right? And you must keep in mind that what is actually a candidate key. Every time we used to confuse in candidate key and primary key, right? So you can say for the better understanding, make a concept that candidate key is a collection of primary key, or if in a table, if more than one key act can be chosen to act as a primary key, so in that case we will call the both the primary keys as a candidate key, right? So these are the candidates who can become the primary key, right? So we will in second NF we have also understood the concept of functional dependency, right? What is partial functional dependency? What are prime attribute? What are non-prime attributes? So this is all about this lecture, right? Hope you have understood this, and if now we for the next lecture we will cover the topic of third NF or more if it comes, right?